Hey, and welcome. This is our 1.9 review video. So if you didn't write it, make sure you write it 1.9. Hoo-yah. Okay. All right, guys. Right up here, we have some vocab. So we're going to be doing some vocab. Whatever I write down, whatever I put on the screen, I want you to make sure you write down. Okay. So the first thing here we got: you can use an equation with two variables to represent the relationship between two varying quantities. This is the key word right here. A solution of an equation with two variables, x and y, is any ordered pair. Okay, so we've talked about ordered pair. Whoop, as I cut through it. X, y, that makes the equation true. So here's our first example. Is 3, 10 a solution of the equation y equals 4x? Okay. This is example 1 from your book. We're just going to do it together. Alright, well first of all, ordered pair. This is an x value and this is a y value. The very first thing you should do is just label it. Once you have it labeled, you want to go ahead and plug it in. So instead of y, we're actually going to put 10, oops, got my color palette up there, equals, and then we're going to do 4, but instead of x, we're going to plug in 3. And it's right next to it, so we're going to put it in parentheses. Okay? So again, what we did is we have the equation y equals 4x, and we just substituted 3 in for x and 10 in for y. Alright, moving forward on solving our equation, we're going to go over here. Okay, we get 10 equals 4 times 3 is 12. Is this a true statement? No. So is 310 a solution of the equation? No, it's not. In fact, y equals 4x is some sort of line. So if we were to graph y equals 4x, let's just say this is my graph. It's really beautiful, I know. Again, everything I write down, you write down, hopefully neater than me. This is my x-coordinate, my y-coordinate. Okay? There's a point at 3, 10. 1, 2, 3. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. So it's right up here. My line is not going to be on that. So my line might go, something like that, where it misses the point. It's not on it. That's how I know it's not true. If it was true, if 10 equaled 10, then I know this point would actually fall on my line. That's what it means to be a solution of an equation with two variables. Let's move on to the next one. Alright, a lot to write here, and we're going to have to talk a little bit here. Inductive reasoning. So you got to make sure you write this down. You might have to pause the video to make sure you get all this down. But inductive reasoning is basically the process of reaching a conclusion based on observed patterns. You can use inductive reasoning to predict values. So we're observing a pattern. For example, if you came into my classroom every day eating food, I would probably predict the next day you would come in eating food. Okay? So I see a process, and I'm going to reach a conclusion based upon what I observe. So the key piece here is your ability to observe that behavior. Let's look at this problem here. Now you're going to write this problem out. Again, you can pause it and copy it down, but we're going to go ahead and write this out together. Ages. Both Carrie and her sister Kim were born on October 25th, but Kim was born 2 years before Carrie. How can you represent the relationship between Carrie's age and Kim's age in different ways? Okay, well we obviously know that one of them's older by exactly 2 years, and if Kim was born before Carrie, okay, we would assume that Kim is older. So we're probably going to say Kim right here, and Kim, I'm going to say you're older, you're greater than Carrie, as I fit it in there. So we know Kim was born 2 years before Carrie. What do we need? We need different ways to represent the relationship. Plan, what are we going to do? We're going to use a table, an equation, and a graph. So we're going to show this in different ways. Make a table. Well, if Carrie's 1, Kim's going to have to be twice as old. Or 2 years older. 3, 2, 4. They're each going to go up every year by 1, but they're always consistently 2 years apart. So this is one way we can do this. Another way we can show this, okay? Another way we can show this, I'm going to start moving this up a little bit here, and so we can see more of this. We can write an equation. We can say x is how old Carrie is, and y is how old Kim is. From the table below, we can see that y, is greater than x. So y equals x plus 2. So Kim is older, and we add 2 years to x. Now it asks us to draw a table, but we're not going to draw a table for this. I just want you to get graph. I'm just going to get you to write the table and the equation. Okay? All right. Go ahead and make sure you get that copy down. If you need to pause right now, but we're moving on to the next question. All right, here we go. The table shows the relationship between the number of blue tiles and the total number of tiles in each figure. Extend the pattern. What is the total number of tiles in a figure with 8 blue tiles? Okay, so we have our first pattern, 1, our second pattern, 2, our third pattern, 3. Okay, so here we go. The number of blue tiles, x. So we get 1 blue tile, 1, out of the total number of tiles. If we were to count them up, 1, 2, 3, 4, 5, 6, 7, 8, 9. 2 blue tiles, I have 18. 3 blue tiles, 27. 4 blue tiles, 36. 5 blue tiles, 45. These are the total. Okay? So 2 methods we could do this. We could draw a graph. So here's an example of a graph where for every 1 blue tile, right here, I get 9 total tiles, right? Okay, again, we get 2, so that'd be 18, matches with my graph. 3, 27, 4, 36, so on and so forth. We can go all the way over to 8 tiles, go up, and see where I'm going to be, and that's going to be 72. Now, I believe this is kind of the slower method. What I think would be the better method would to go ahead and actually use a different piece. So we're going to go ahead and, not do that. And here we go. Look at that. It just moves all around. We're going to move this up here. Didn't like that. There we go. Still doesn't like that. Let's go ahead and shrink it. Sorry. Boom. There we go. Wow. This is being very temperamental today. Okay. Sorry. We can't get to it. I can write it down though. So let's just move this out of the way in general. And we'll move on to step 2. Okay? So I'll leave this so we can still see. Alright, and we'll erase all this jazz here. Sorry about that. Alright, method 2. Boom. Here we go. I think we're now ready. Method 2 would be to write an equation. Now this is our preferred method. We want to, if we can, write equations. They're faster than drawing pictures. And this is algebra. That's what we're all about. Okay? So over here we can see the number of blue tiles is x. The total number of tiles is y. Okay, well, for every 1 blue tile, I have 9 different tiles, right? So I could say 1 blue tile, we'll say x equals y. That's how we want to start the equation out. But does 9 equal 1? No. So how could I change this to make this work? And I keep messing this up. Sorry about that. How can I... Whoa, what did I do? I'm sorry. Alright. What I can do here is go ahead and say, alright, does this work? Does 9 equal 1? Y is the total, x is 1. So let's see if I can write an equation that would make this true. Okay, well if I added 8 here, that would be true, right? 1 blue tile plus 8, that equals 9 total tiles. Let's see if that works for 2. Because if I have 2 blue tiles, I should end up with 18. So let's try that. So I plug in 2 for x plus 8. Does that equal 18? No, that doesn't work. So adding 8 to the end does not work. Okay, not going to work for us. What should I do instead? Well, if I can't add, dividing obviously won't work. We got to get x to be bigger. Dividing makes it smaller. Subtracting won't work. The only thing I think of is multiplying. Let's try multiplying this by 9. Plug in 1. 1 times 9, 9. Perfect. Let's try 2. 2 times 9, does that equal 18, what our chart says? Yes, it does. That checks. So that must be our equation. So instead of using 2, we want to know how many at 8 tiles. So let's go ahead and try this out. So y, we don't know how many total tiles. When we have 8 blue tiles times 9, 8 times 9, that's 72. So that means y must equal 72. So we're taking a look, inductive reasoning, we're trying to figure out how this is going to work. And the way it works for us is in order to draw an equation, we can make a conclusion. Okay? Alright guys, that's it. Sorry about the mishmash of what would happen, but anyways, there you go.
Alright guys, have a good one.